I want to introduce everybody to our guest for tonight, Mr. Jacob Smith, who is a North Carolina State geologist. And he's going to be talking to us tonight about the kind of work that he does and the schooling that he went through and what is so interesting about your job. So feel free to take it away, introduce yourself, say any little intros you wanted to go through.
For sure. Yeah. Thank you for giving me this opportunity to speak to an audience, right? To get to express what my experiences is. And I hope that some of these audience members can take away my experience and apply it to themselves, right? That's the goal.
That's the goal.
So my name is Jacob Smith. I work with the North Carolina Department of Environmental Quality. And within that department, I work as the environmental specialist within the Division of Energy, Mineral, and Land Resources. So let's back it up. The North Carolina Department of Environmental Quality is a state-run organization that is essentially in place to ensure the environmental quality of North Carolina assets as it relates to minerals and land resources and water resources and all these other things. So DEQ is a big umbrella term, NCDEQ. There are many, many divisions in DEQ. The division, like I said, that I work in is the Division of Energy, Mineral, and Land Resources, or DEMLR, DEMLR for short. Yeah, it's not a great
It's a fun acronym. I like that.
Best name that we have. There's other better names, but DEMLR is the most easy to remember, I think. So within DEMLR, there are many other programs associated with environmental quality. So I work within the dam safety program, but there are many other programs, like I said. So, the North Carolina Geologic Survey is one, the stormwater program is one, the mining program is another, and the sediment and erosion control program is another. These are all parts of the machine that is the North Carolina Department of Environmental Quality. And so, like I said, working in dam safety, what I do is, from a very zoomed out perspective, is I look at proposals and plans that are being submitted by applicants or consultants to review if they wish to impound any degree of water or dam up any water. So it's probably worth explaining what a dam is. Maybe not everybody understands, exactly what a dam is. So think of the one that everybody knows, the Hoover Dam, right? So everybody knows the Hoover Dam, and from a very zoomed out perspective, what a dam is creating a barrier to the normal flow of water so that a reservoir can be built up on the dam, the upstream side of the dam. It can be used for recreation or, farms or whatever. You want to store that water for some use, right? So that's what a dam is. So dam safety, what we do is whenever somebody wants to, say, put up a new pond, or a good example is, let's say, a golf course chooses to they want to have a new pond in the middle of the golf course so it looks nice. What they have to do is submit to us various applications that have to be reviewed, right? There are many things that you got to look at, make sure it's safe and that it's designed properly. Essentially comes down to due diligence, making sure that they've done their due diligence as the owner and that the engineer's done their due diligence, and we review it. So an application will come in and it will be split up amongst all of the various specialists that we have. My particular specialty is in jurisdictional determination and hazard classification. And what that means is I have to look at where the water may go if the dam failed completely. If the dam failed completely and we need to see where the water goes downstream, we have to run a model, right? We don't want to effectively breach the dam. Yes.
I have a question. So isn't the water already going to be going that way before you build a dam? What is the difference between figuring out what happens if the dam breaks versus
So
What happens if you just let the water keep flowing?
yeah, so the deal is when you have a normal flow, you're not creating additional upstream pressure, right? So when
Right.
you dam up that reservoir, when you create a reservoir, you're adding a ton of additional pressure brought on by the water on the upstream side. A good rule of thumb is for every, at least in open diving water in open ocean, for every 15 feet of depth, you are essentially adding 1 atmosphere of pressure. So think, if you have a dam that is 200 foot tall, that's a lot of pressure being added every 15 feet, right?
Oh, okay.
Have to do is when that dam is, we simulate a catastrophic failure. So not a controlled release. Ideally, a dam operates and it provides a controlled release downstream so that nothing is impacted adversely. But we all know that catastrophes happen, you know? So what we have to do is analyze these dams per the worst case catastrophic scenario, i.e., the entire dam is opened, rushed all the water out, who's impacted. And that goes back to what I do is I run these models to simulate these dam breach scenarios to determine if there is any impacts downstream that need to be of noted, right? So let's think of it like this. If you have various hazard classification based on what's impacted. So high, intermediate, and low. The thing that you need to know is that for high, think if that dam releases and 5 houses are impacted and then an orphanage and a firehouse are all impacted. These are all things that we need to understand, we need to acknowledge, and we need to prepare for. So it's probably a high hazard dam.
Right.
Whereas a low hazard dam, it's a farm pond, it's just being released into the existing river
Oh,
downstream.
so the cows can get swept away, but the orphans can't.
Well, the
Like the farm.
important, but we care more about the houses ourselves.
Right. Right.
But when we see that there's no impacts to affect citizens of North Carolina, we can offer hazard classification. So enter in what I do is hydrology and the hydrogeology. I particularly focus, I would consider myself more of a hydrologist rather than a hydrogeologist.
Okay.
I surface water flow more so than the subsurface flow.
Can you
But
explain what the difference is between a hydrogeologist and a hydrologist?
for sure. So a hydrogeologist primarily looks at how groundwater flows below the subsurface, where it goes, how it might react to recharge and wells that may decide to use up some of this water. And that's a hydrogeologist looking at the subsurface, right? Geologists like the rocks below the surface. A hydrologist is more focused on how a basin or a watershed may respond to surface runoff. So it's more of a let's see what happens at the surface level versus what happens at the subsurface. But to be quite honest, you cannot talk about one without acknowledging the other, right?
Okay.
Surface water doesn't operate independent of groundwater. And especially when we talk about dams, you have surface water constantly applying pressure, but then you have groundwater constantly trying to go under the dam and find a low pressure head. So those are the two pieces of it. But what I look at is the flow across the surface water downstream. So like I said, when I'm looking at a hazard classification, I'm looking at who's impacted, who's hit, and how many people might be hit, how many houses could be impacted.
Mm-hmm.
And so that's really, from a zoomed out perspective, what I'm doing every day is creating models, running models based off of applications that the consultants have put together, submitted, and displaying their due diligence. And we review it. We make sure we run these models and we ensure that it is what they say it is. And then after we review everything, what happens? Well, we typically will give the applicant approval so they can go ahead and do what they want to do with the water in the dam, or we will request additional information. So we need you guys to clarify a little bit here. You need to add a little bit more data because we're not sure here, right? Those are the two parts to it. That's essentially zoomed out who I am, what I do.
What's the difference though between some kind of business that or land developer that wants to build something on their private property and they have to go to a consulting company that's not related to the government? Why do they have to go through you with the government? Do they have to do that in addition to finding somebody else to come onto their site and investigate the other things there?
So so there's many parts to a project, right? So essentially, whenever we think of even an apartment complex, or some private owner wants to turn his farmland into a high story, right? What they would have to do is, obviously, the consultant may not feel like they have to, or may not know that they have to submit something to us. And then at that point, we're relying on neighbors, or unfortunately, catastrophes to happen to where then we know a dam existed. So,
Oh, so
Carolina,
you want people to snitch a little bit.
if it turns out, say I feel like we would all be warranted in calling the state if a dam was built upstream of my house with no regulation. I'm going to be worried. Well, I may call the state, and I may say, I've got just a concern here. Can we just get eyes and just see what it may be, what the issue may be?
Does your team look at natural dams, like things that are made from, one, animals, and two, fallen trees, anything? How do you go about that if you were to find out that there is a natural dam that is huge, and if it breaks it will be catastrophic? Are you guys in charge of like removing it?
It depends, and so obviously I can't speak on behalf of the department, but what we have seen is beaver dams, right? These are common things that get set up. If there is a danger there presented to people downstream, then we may certainly make a recommendation to the property owner, or whoever may own the particular parcel that this beaver dam is on. We will make a recommendation. Hey, you may want to consider, releasing or getting rid of this impoundment here because it's creating unnecessary risk downstream. So there are natural cases which certainly come up. It's not as often because most people don't even realize what they're looking at when they see a beaver dam. You know what I mean?
What does a beaver dam look like? I'm always picturing it like sticks and mud, just like packed together with,
Yeah. So here in North Carolina, it's so deep in the woods, people may just assume, oh, that's just brush. That'll clear out. That'll move on naturally, because it looks natural. With respect to a man-made dam, obviously, right? So a man-made dam is clearly a dam, whereas a natural dam, a tree in the riverbed, or a beaver dam is harder to spot if you don't know what you're looking for, if that makes sense.
Mm-hmm. All right, that does make sense. So when you're talking about these models of catastrophic flow, does that take into consideration the stuff that'll get picked up along the sides? Because I'm thinking, like, whenever I think about like a catastrophic flow where there is just, I'm thinking usually of like debris flow going through that.
Yeah.
Like, what kind of debris goes into a dam when a dam breaks? Like, I guess I'm circling around to the question, what are dams typically made of? And when that dam breaks, are the materials of that dam going to have an impact on everything downstream?
That's a good question. So I'll answer the part where what are dams made of. So typically there are 3 dam categories that you have. You have earthen dams, concrete dams, and gravity dams. For what we deal with here in North Carolina, for most cases, is earthen dams. So that is essentially taking, material that is more or less impermeable, compacting it, and filling an existing valley with that compact dirt. And there are numerous factors that go into what is inside of the dam, what is the core made out of. So some, for example, some dams, some earthen dams may have a concrete core running through the center, and that aids in preventing any sort of seepage through the dam as the pressure tries to go from high to low.
Mm-hmm.
The other types are gravity dams and concrete dams. And so these are the dams that typically, if they were to break, you can picture, you could safely assume that there would certainly be some degree of debris flow associated with the concrete of that structure. The dams usually aren't much taller than 25 feet. And so to discern between what is debris flow versus what is just catastrophic due to the nature of the breach is hard to determine for an earthen dam. So the models, it's not as easy to decipher that for the earthen dams. For the concrete dams, it's obviously a little bit easier to predict, right? You can imagine that it's going to just err on the side of caution and conservativeness and say that if this breaches, the water is one aspect, but then all of the associated construction material is another aspect. And so, yes, these are certainly included in the inundation zone when we look at what is downstream, what is impacted.
Not just the materials of them, but also like not just like chunks of it, but like materials and stuff that gets dissolved into the water, right?
So like for larger dams, for really large concrete dams, I've heard of other states with breaches or releases, uncontrolled releases, where, as you can imagine, sediment settles at the bottom of the dam. So as water approaches the dam and that energy dissipates, you have plenty of sediment settling to the toe of the upstream side of the dam. So it's totally something that needs to be thought of when doing even a controlled release. You don't want to release too much of that new sediment that has been applied to the base of the dam, because that can have adverse effects downstream as well, right? Mm-hmm. So you sediment into the riverbed and disrupt flow entirely downstream, you could really ruin a lot of things. So there are numerous long-lasting failures associated with, or long-lasting issues associated with potential dam catastrophes, right? Mm-hmm. So it's important to really, when we look at a dam and look at how water may be affecting the downstream impacts and what may be influenced, we have to include all of those in our process. We have to think, well, there's going to be sediment introduced into this river stream. There's going to be, debris flow associated with this. It could spark a landslide, even if it's in high enough altitude, right? If it's up in the mountains, it could certainly, if the velocity is there, it could displace enough volume and cause a landslide. So we err on the side of caution in most cases, where if it seems high hazard or could potentially impact people, it's safe to just say, this is what we believe, this is where it needs to be, unless the consultant can obviously provide additional analysis to show that this is not a concern we need to be worried about. So it all goes back to the consultant doing due diligence and proving to us that this isn't an issue. So if we call it out as being an issue and they disagree, the consultants have every right to conduct additional analysis and prove otherwise to us.
So those are people who are out in the fields looking at it.
So the consultants, yeah, in most cases when I refer to consultants, I'm referring to like the private sector people.
Oh, okay, gotcha.
So the engineers that were contracted by the golf course to design the dam. So, right. Ones, AECOM, Terracon, all of the big ones, they are oftentimes consultants associated with this type of work. So if they've done their due diligence, should get back to us and let us know what they find, right? So it might be worth explaining what a consultant is. So a consultant is somebody who, when a private citizen perhaps doesn't have the means or the know-how to conduct a project, to build a property, they will go to somebody professional in the industry that is experienced in this particular field. So you have consultants who may be specialized in dam design, as well as consultants who may be specialized in erosion and sediment control. So then it's up to the owner to find the appropriate consultant for what they are trying to do. So, and then the consultant must return to us all of their findings and details.
Are the private citizens required to, you know, speak to a certain list of consultants, like a certain kind, or is it just like, all right, it's evident that you didn't speak to a consultant on this because now something bad has happened?
Yeah. So yeah, you see, it can definitely be across the board there. So yeah, so you are correct. Yeah, so consultants should be doing their due diligence and submitting things to us, because obviously you don't want to be caught after something happened.
No.
But private citizens, they may not be as informed on the process, and they may just simply not understand that, I have to submit appropriate applications to get approval to do this, right? They just may not know. And if that's the case, then we can work with that. We can discuss that, and we can try to come up with a solution between the owner and the state to make it where it is up to code and falls under regulatory status as it should. So it's not an end-all be-all if you didn't know, but it's something that we need to address if we see it.
This is we're getting so deep into this. I want to circle back. How did you get involved in this? You are so very knowledgeable, and you mentioned when we had like a little preliminary meeting a couple weeks ago that, you are on the side of communication at your job. Like, you're the guy that they would put in front of the media to explain things, and you are doing a fantastic job at that. Like, this is wonderful. How did you wind up knowing so much about this and doing this job?
So it's a bit of the way that I got to where I am now is, I would say, not what we are taught as undergrads in geology to think is the normal way. And that is to say, in undergrad, at least at my university and with my circle of people and friends and professors, the idea was you go to undergrad, you then go to graduate school, and then you find a job. But what I've discovered in my own personal experience is that's a nice way to put it, but that's not always how it goes, right? So for me, I graduated in 2017 from East Carolina University here in North Carolina with a degree in general geology and a concentration in coastal marine geology, not dams, very clearly not dams, right? I did what most undergrads do when they graduate. I didn't have a plan. I had nothing lined up, had no job lined up. I just assumed that once I graduated, I would put in and find a job. And I feel like a lot of undergrads kind of have that mentality, is I'll just find something. And it's not always that easy. It's unfortunately not always that, especially level jobs asking for, that 3 years experience. But it's an entry level. So what are you to do as a young aspiring graduate, fresh out of undergrad? For me, I meant, because I was not meeting the qualification standards here for the country or for the state that I was working in, I said, well, I'm going to have to transition. I'm going to have to make a leap to another location where the jobs are more abundant. So that's part of what I had to do. So I moved to Texas. I went to, obviously, oil and gas country, right? Everybody knows that's where you go for oil and gas. So I figured, let me get my foot in the door. There are more plentiful jobs here. Let's just give it a shot. I worked as a mud logging geologist. And if anyone knows what a logging geologist is, it's not an easy job. It's about as low rung a tier that you can have as a geologist coming out of school. But the idea is, it got my foot in the door, right? It got me into the industry where I could not do before. And ultimately, I determined while out there, I don't like oil and gas. It's not where my passion is. It's not what I want to do. So that pushed me into environmental consulting, which is where I started to make the turn to where I am now. So I got a consulting job, and I loved it. It was an environmental specialist one, a lot of field time, got to go all over the state, see all different things. It was great, a lot of fun. But I became increasingly aware that if I want to move up within my industry, I'm going to need more experience. I'm going to need more degrees. I'm going to need something else. And so that's what actually got me to go back to to graduate school to get my master's degree. I got my master's degree 2019, 2021. I got my master's in geophysics, and I had a spare GIS certification on top of that. And so after I graduated, I had all this new experience. I had all this real world experience. And I said, well, let me try to go back to North Carolina. Let me get those jobs that I couldn't apply for, 3 years ago.
Hmm.
I got my experience in Texas. I knew I wanted to come back home. This is where family is. And so I just started putting in jobs everywhere, as you do. You just throw them out there wherever you can. I found something I saw North Carolina Department of Environmental Quality. Lots of jobs, because North Carolina cares a lot about the environment. And so there are plenty of positions open and available for people who want to be a part of that industry.
Take notes if anybody lives in North Carolina and cares about the environment.
Plenty
Wonderful
opportunities with us that are ready to go. But once I got a call, it was, I put in my applications, and it was as simple as, the dam safety program giving me a call, making an offer, and I was like, this is it. I get to go home. I get to jump into it. So once I started with dam safety, I just progressively I learned as I went what it meant to be in the department. And a huge part of what I do is consulting with law, with state government. Many things are associated with operating within the confines of established law, right? So everything that we get submitted to us, I would have to refer back to the dam safety law. And this was where my training, where I started learning more and more, because these dam safety laws,
these damn safety laws, damn them.
Damn laws are written by professionals in the industry, and they know what they're doing. So if you just take the time to read, you'll learn quite a bit. And it turned into, because I had the GIS experience, I was a natural fit for modeling the groundwater or the water flow across the surface. And I inherited that position at a certain point, because nobody else really had the experience in GIS. And I just continued to apply what I learned from geophysics in undergrad to what I was doing every day, watching this water flow. And that's where it's gratifying, because I'm getting to use what information I learned for once, rather than mudlogging, single-mindedly taking samples, writing down information, and sending the samples off. It wasn't a gratifying experience. This is a gratifying experience, right?
When you were in grad school, though, did you do like did you do a degree that was all just coursework? Like that was like the straight shot through it?
So that's the other thing, is when I went to grad school, when I went to undergrad, I'd always heard, you got to do a thesis. Thesis is where it's at.
That's what everyone says.
It is, but when I got to grad school, my professor had a clear discussion with me, said, do you want to continue on to perhaps get your PhD, or are you just looking to get into the industry with additional experience and knowledge base? And I said, honestly, I just want to get into the industry with this additional experience and knowledge base. And so he said, well, I recommend non-thesis. So I chose non-thesis route when I went to grad school, straight 1 year, 2 years in and out. And to be quite honest, it was one of the best things I could have done, because it was night and day upon graduating with the master's degree and certificate. I didn't get any more jobs than I was getting before, but I was getting more recognition. I was getting more callbacks. More people were looking at what I had done, and it opened up more opportunity for me. Right. So non-thesis was best for me, because I was able to get in, get out, and go ahead and start making back some of the money that I'd lost going to school. It's expensive going to school these days.
Oh yeah. And you went to a state school for your undergrad, right?
Yeah, I went to the university, or I went to East Carolina University here. Yeah.
I don't know any of the state schools in other states.
So it's a coastal school, you know, relatively close to the coast. Yeah, it was a fine university, great geology department. So if anyone's looking for a department to get involved with,
Yeah.
Fine University, can't recommend them enough. Um, but yeah.
Awesome. I have one question for you. I have to get up and draw something for you though, because there is this dam in my favorite park, and I don't know what its purpose is. I know it's a weird dam. Water flows through it. Hang on one second. I gotta grab my little drawing set up here. Wait a minute. I gotta find myself a pencil. Okay. So there's this dam in my favorite park. So like, here's the one from above. There's the river, and it's got these like two parts to it. But like when you're looking at it, it's like water is kind of just like flowing at it in like bursts. I'm trying to draw this. It's like concrete and we can walk across it. It's like a little bridge. We sit down on it and have a picnic. But like on one side the water's higher up, on the other side it's lower, and the water is like falling down a little waterfall into the square, into this little square thing, and then it's like gushing on the other side.
No, exactly what you're talking about.
I don't think anybody was picturing this, right? Except for the dam expert.
I had you right there. I knew exactly what you were referring to.
Awesome. Okay.
That's called a low-head weir dam.
Okay.
What these are is most often, so this was within the run of the river, right? So it was a river. It wasn't necessarily impounding, but it was slowing down the water and it was just flowing over the top. These are designed, these low head dams and rivers are designed to help impound or slow water upstream. So it's not effectively impounding water, but it is slowing down the rate at which water flows through the river, which creates a backup upstream as the water flows slowly over top of it, because while it is not a dam, it is still interrupting the normal flow of things.
It is a bridge. Like the water isn't flowing over it. Oh, I guess it kind of is. It's flowing through it. Yeah, yeah.
So it's essentially what these are designed for is to create, most cases, recreation upstream. You say it was near a park?
Yeah, we have to take the kayaks out of the water and then go down the little steps, and it's lots of fun. No.
So it's there to mainly aid in recreation, to create more opportunity for things like kayaking is a prime example. People like to do recreational kayaking, but it's hard to do in a river that has very little depth. There's nothing to float in. It's hard to do. If you got rid of that low head dam, it's safe to say that the upstream portion of that water may not be as deep or as expansive as it may have been with the dam, with that low dam. It's just there to help slow down the flow, but not stop the flow. It's going to slow that flow down, make the water upstream increase capacity, and then, like you said, downstream it's usually a big waterfall style, or it's gushing water over the edge.
It's a small drop though, but it just flows so fast.
So
all of the plants in the water are like getting sucked down the waterfall. It just looks like a vortex of water and green stripes. Very, very cool to stare at.
Vortex. So that water, there's some physics going on there. As that water comes over the top of the dam, due to the speed that water is going over top of the dam, it is going to impact the surface below, the existing river bed or whatever, and it's going to fold back in on itself. And then eventually you get a feedback loop. As the water comes over the top of it, you get a vortex right below the dam, which is honestly, fun fact, low head weir dams are some of the most in the rivers, are some of the most dangerous dams in North America.
To get to be in as a person who can drown?
Because they are more likely to not catastrophically fail, but somebody that is just swimming gets pulled into the vortex, unfortunately. So low head dams are some of the most dangerous you can see.
That is why they say no swimming by this thing, and that's why they say no dogs in the water, even though our dogs go in the water.
They're pretty dangerous, yeah. But
Hey.
they're useful for recreational purposes, but dangerous to be around.
Water. All right, I'll make a note of it. Shoot, that's really interesting. So what is something like a higher weir? What is that? Is there a difference between why they're used, like lower over higher?
So there's no high dam, higher weir dam in most cases. You might see, think of a typical concrete dam. You could potentially see off to the side, so the spillway may be designed as a weir to allow normal flow to pass over the dam at a controlled pace that doesn't adversely affect things downstream. So that could be higher technically in the elevation, but really weir dams are all designed the same, to slow down water and to help impound but not stop the water. Because think sometimes you may have environments downstream that rely upon that water. You don't want to stop it completely. You still want to release that water for animals or environmental purposes. So the weir does a great job at giving you the water you want upstream and also letting you control the water downstream.
Wow, that's very cool. Oh my gosh, I'm gonna look at my pictures and I'm gonna send you a picture of this dam, as I want you to see it and like to verify. That just sounds so cool. I'm going to invite anybody who's watching to ask some questions for Jacob.
So I could talk a little bit about maybe while people think of questions, maybe I can go into a little bit normal or a typical day might be like for someone that's doing what I'm doing. Do you think that's appropriate?
Yeah, we actually have, we did get 2 questions while you were saying that. Someone asked, how do you know the inches of, how do you know how much water is needed downstream?
Okay, so there's a calculation that can be done that we call it the minimum flow calculation. And so this is actually goes beyond dam safety, and we actually would put this in the Division of Water Resources, because we don't necessarily have to worry about how much water is being released. We just need to make sure that it is being released. So the Division of Water Resources will do a minimum flow calculation, and they'll give you, you need to tell the consultant or the engineer that they have to release X number of cubic foot per second, as to not adversely affect the downstream environments. In most cases, it does not seem, at least per what I've seen, that the minimum flow requirements are any greater than what the engineers had already considered, right? So our engineer doesn't want to get in trouble with another department in, the DEQ. So the engineer in most cases has already submitted the appropriate flow requirements downstream, and we don't have to calculate it, but we can certainly verify it.
All right, that's helpful. I remember you had you wanted to know what kinds of questions people are going to be asking during this, and I told you there will definitely be questions about GIS. There's questions about GIS. Right. How critical is having ESRI or ArcGIS product knowledge versus knowing some open source tools?
I would say, for me, the ArcGIS Esri suite of software, ArcGIS Pro, ArcGIS Online, Web App Builder, Story Maps, crucial to my everyday. I could not do the job that I do without that information and that knowledge base. So
that's comparable to like open source GIS, like QGIS. If you learned on QGIS, is that transferable to when you go into a job that's requiring you to use like Arc?
For sure. Yeah, it's a much easier step to learn ArcGIS Pro or Arc Pro or whatever, having some knowledge of the interface associated with GIS. So QGIS or whatever it is you may want to use, you can certainly take that step and learn ArcGIS. It's not totally out of anyone's capability. The issue would be is if you had absolutely zero experience in GIS, this would be a hard job to do because, like I said, you have to look at the downstream impacts. And so it's hard to do that without utilizing various shape files of buildings or roadways or bridges or utilities. You can layer all these things on a single map and say, boom, 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 these process or these properties are all going to be impacted, right? So you can quantify that data with GIS or ArcGIS Pro. Super important. Highly recommend getting a comfortable base in GIS.
Right. So everyone who doesn't know, GIS is it's geographic
information system. It's essentially we're geologists, right? So we know how geo works, how geology works, but it's really not so useful in today's day and age to be able to just put it on a map, just in the field, right? You need to have a hard copy and a soft copy. Mm-hmm. Be able to refer to these things moving forward without saying, did my pencil smudge this line on my field map, right? If you can put it in a database and save it on a hard drive, well, then you and anybody that comes after you can check this data out and look at it again.
Think about Google Earth. Google Earth is a very unique kind of GIS. You are able to make points, you can make routes, you can make lines, you can make polygons, you can put data, you can like literally import data from a KMZ file. You can literally take stuff, and I did this all the time in college. I did stuff in Google Earth because I knew it would be easier than doing it in Arc, and then I would export it from Google Earth, put it in Arc, and I'm like, hey, I did.
That's the thing, is if you're somebody that just wants to get into this field and that's the only way you currently know how to do it, if you can do it well and do it confidently and produce results that you're happy sharing, do it that way. Start in Google Earth Pro and export those results to ArcGIS, but be willing. The main thing is, if you're going to put it on the map, if you're going to put it on any map, you have to have a reason why it's there. So if you can discuss it and confidently state why this feature has been plotted, I don't see a problem with using anything that's Pro or QGIS or Google Earth, as long as you know what you're doing and can confidently say why you've done it.
That's really reassuring to hear. I always thought it was weird that I found shortcuts to things. Like, as I know how to do it in Arc. It's just a pain in the ass, and it's easier to do it there because I have a better, more easily movable globe of a map rather than have to like use all these different key shortcuts and memorize them. ArcMap, ArcGIS, very complicated program in my opinion. I learned GIS on Grass GIS, which is another open source program. So it's free-ish. QGIS is a really good one. It's entirely open source. It's made from people who open source. It's free to use. You can download it. There's updates that come out from it. You can download other like tools to go into it. Like it's DLC for the program, but it's like a little tool to help you do the thing better. Does that make sense? I'm trying to describe what like an open source GIS is. You're downloading these special additional tools that somebody else made, and they're like, high five, I'm gonna give this to you. We're all collaborating on this together, and we're not charging you hundreds of dollars a year for a like huge license for it, which is what Arc does.
Yeah, and that's the thing. Totally fine. The only issue with that kind of software is it goes down to what can you trust, right?
Exactly.
One thing is who produced this particular tool, and did they do it right? I mean, that's the one thing. But for the most part, yeah, I would say shortcuts and doing things easier is totally appropriate as long as it produces results that you're comfortable and confident in.
Yeah, that's good to know. All right, we have another question. Can college research positions for GIS have as much of an applied impact as industrial placements?
Industrial placements. Do you have an
Like jobs, I guess. So like if you did research in college with GIS, does it have as much of a hiring impact as having work experience with GIS?
This sort of goes back to any sort of undergrad research project, right? You can sort of, this answer can go towards any of those. It can be very helpful in the right situation. If you're speaking to a particular company that weighs heavily undergraduate research, then yes, that can certainly help you out and give you a leg up. But as we know, most of these most of these companies that we apply to take 4 or 5 seconds to glance at a resume, right? So unfortunately, that means not everybody will look at your research project that you did in undergrad for GIS or geology and take the time to read it. And so it's just situational. It's case by case. And that boils down to researching the company that you're applying to and catering the application that you're putting in to what they're asking for. So if they're looking for strictly skill-based, we want to see as fast as quickly what you can do and how well you can do it. That's great.
That's where the cover letter is really important, because you can't really put all that stuff front and center on your resume, because they're just not going to look at that. But you really put it in the cover letter, really just go heavy on it.
Yep. Give them the opportunity to look at it, but understand that it may not make a difference. It's hard to say what's going through the minds of these recruiters or these hiring managers when they're hiring. And I think most cases they just zoom through it as fast as they can, unfortunately. I wish undergrad research played a more important role. I may have been able to find a job right out of undergrad, but for me...
Did you do research when you were in undergrad?
Yeah, I had a little bit of research. I looked at hard rocks deformation within the Linville Gorge wilderness area here in North Carolina, using electron backscatter diffraction microscopes to measure C-axis strain for locations that were becoming more or less distal from the fold line, trying to see how that C-axis may change, or deformation may change, or quantify that change as you get closer to that fold hinge. But as cool as it was, really learned a lot there. Not one job that I applied to said, I like that research that you did. And that's the way the cookie crumbles.
Were you applying to geophysicist positions? That sounds like it would be very helpful knowledge if you're applying to some kind of position that involves specifically like hard rock physics.
So I thought it would be, but again, it boils down to also they want to see, how much industry experience do you have on top of that research experience. Research experience is great and they like it, but it's tough to do anything without having a foot in the door in the industry at some point. So there's a couple of things you can do. You can know somebody within the industry and network with them, and hopefully they can help you, and I encourage everyone to lean heavily on networking. Or you can do what I did and stumble out of the gate initially after graduating, but through experiences, pick up your stride and find a job that you really enjoy. And that's where I am. After I stumbled out of grad or undergrad through various experiences within the industry and back in school, I picked up a stride and I found a job that I'm really happy at. But it took time. I graduated in 2017 and I've just gotten this job that I really love in the last year. So just go show that you got to be patient sometimes. And sometimes you got to take jobs that you maybe didn't want to take initially, but just get that foot in the door.
Oil and gas. And then you go, nope.
And yeah, that was for me. I was like, this is not the industry that I want to be associated with. And it just didn't feel gratifying. It depends on what feels good to you. What do you like to do?
Can you incorporate filters in dams to reduce pollution?
Filters in dams to reduce pollution.
Probably like a garbage catcher. That's maybe what they're thinking of.
Yeah, I can certainly see Yes, yes, you could do that, but it boils down to what everybody looks at when they do those kinds of things is it economically going to bring in anything, right? So while we would love to see that, people who construct these dams, if it's not profitable, they may not do something like that, right? So it boils down to why would we do it if it is there to just create a bin for trash? Well, who's going to come out and pick it up? We're going to have to come out every month and grab this material and take it somewhere. And then at that point, most consultants would say, no, thank you. That is not for me. But
Yeah.
I've certainly seen designs online and otherwise that where they have put a trash filter in front of a dam, maybe one of those low head weir dams, and they'll catch things as they come down. Um, but it's not as common. Luckily, our dams here in North Carolina are not too polluted. So we don't really need the trash guards or trash filters, thankfully.
That's good. That's nice to hear. Someone asked, do you have any experience with beaver dam analogs used for stream restoration and reduction of nitrate and nitrate phosphate? You can also add GIS knowledge transfers to many other fields. This is a question that sounds like it is so specific. I don't even know what it means, but you probably do.
That one I'm not too sure. That's you're getting above my head there, unfortunately.
Oh man.
Not able to help with the nitrate states and how that may.
You've never done like water testing for nitrates and phosphates?
Not for dam safety. When I was a consultant in Houston, I did have to do groundwater sampling for various sites, but not in anything that was run of the river or it was all just typical groundwater wells that were needing of samplings, but nothing run of the river for me like that.
Gotcha.
Unfortunately, sorry, couldn't answer that one, guys.
All right, we're wrapping up. Instagram will cut this off at an hour for whatever reason, but I think we had a good amount of it. We got a lot of questions in. I was very happy to hear so much like detail about this kind of work. That's amazing. I wish we had time to talk about like what your day-to-day is, but you did really give us a good idea of the kind of work that your department does and how the whole Department of Environmental Quality, am I correct? There we go. Pulls together, and everyone, just care about the environment. Dam safety is a part of that, because it also, you're caring about the people who live in the environment, which is very important.
Yeah.
Closing remarks before we get cut off?
Just to say that, if you're an aspiring graduate and you're trying to find a job, be patient and be willing to cater your resume to jobs that you need, that you may not want, but that you need. Get your foot in the door and then begin to work towards what you want. And just don't feel discouraged. It's easy to feel discouraged when applying for jobs. I get it, but keep your head up, keep putting them in, and eventually I'm confident anyone can find something somewhere.
That's very inspirational. Thank you so much for this. This has been extremely helpful and insightful, and I have learned a lot about dams and also about the workforce and the kinds of things that I can expect when I go to apply for jobs out of grad school. So thank you so much, Jacob, for joining us, and I hope you have a great rest of your night and a good weekend. Go back on Monday and you're going to be looking at dam models.
Yeah, looking at all these
those models.
Got all these damn problems, damn models, give me all these damn issues.
There's so many puns. I love it.
Great. Yeah. So.
All right. Well, thanks everybody for watching. Hope you enjoyed and hope you learned something. Bye, everybody.